For laser processing equipment, that XYZ respectively represents different moving directions of the cutting head. These are the XYZ axis. The pipe cutter also has a B axis to control the rotation direction of the pipe. There is a W axis inside the cutting head to control the lens moving up and down. The X-axis represents the movement of the machine beam. The accuracy of the beam needs to focus on its straightness. The Y-axis is the direction in which the cutting head moves along the bed. Just pay attention to straightness. At best, pay more attention to the perpendicularity of the X and Y-axis. But now the laser cutting machine, most are double Y-axis drive. Naughty Y could be like this, or like this. Of course, ideally, it should be parallel to the left Y-axis. But when you look at it in 3 dimensions, oh my god, how did my machine get set up like this?
Oh God, please, no! No!
Fortunately, at present, most people use integral beds. These mounting surfaces, most of them are formed in one machining on the gantry milling machine. But there are also earth rail machines. On-site installation requires more attention to assembly accuracy. Pay more attention to the installation environment of the ground cannot be deformed. In particular, the frozen soil layer in the north will be affected by the change of temperature difference and cause the change of foundation, cause track deformation. So if the plant is our own, it is better to do a foundation pouring. Now the laser power is getting higher and higher, we are more inclined to install ground rail equipment.
Nice.
But the machine with the above problem is not operational, so you're not likely to buy it. Then the following may be common. In the first case, the X and Y axes are not perpendicular. This was very common on early split beams. Will cause the diagonal deviation of the cut rectangle to become larger and larger. The reason is that the connection between the slider and the beam is loose, completely lost the factory adjusted verticality. Fortunately, most of the current CNC systems have the function of reserving diagonal compensation. The assembly error of XY axis is relatively easy to check out. The easy way is to cut small round holes. Manufacturers with high standards will use laser interferometer detection. Then the circular deviation is checked by quadratic projection on the small circle cutout. Roundness deviation test. It is a comprehensive test of machine tool assembly accuracy. Second, the Z-axis is not perpendicular to the machining table. It seems that the size and accuracy of the machined parts are not affected. In fact, we need to worry that when cutting the border, it will cut into the area outside the plate. The third kind, it is a common problem that the cutting head is not installed vertically. It will cause the 4 facets of the plate to be inconsistent. You can use iron plates and photo paper, Z-axis vertical one-shot, and the paper surface one-shot. You can also use cellophane tape instead of photo paper. The size circle is concentric, which means that the cutting head is perpendicular to the surface of the plate, not vertical. You need to watch the video to adjust. The fourth is an accident. It's the straightness of the W-axis. It's the straightness of the W-axis. The phenomenon is zero focus alignment, resulting in hot nozzles, poor cutting quality, one-sided spark spray. After eliminating light path contamination and nozzle causes, it's pretty much the only possibility. Here it should be noted that the test methods and test objects for the W-axis and the Z-axis are different. And the pipe cutter part, no matter what kind of cross-section shape of the pipe, it is fixed by the 4 jaws of the chuck. Numerical control systems also default to this identification of pipes. Therefore, for the numerical control algorithm, the rotating center point of the chuck needs to be struck with the intersection point of the peripheral rectangle with the smallest section of the pipe. The general chuck structure is composed of 2 pairs of jaws and a disc bearing. We split the cloth into two pairs, divided into Group A and Group B. The clamping action of Group A determines the position of the pipe in the vertical direction. The clamping action of Group B determines the position of the pipe in the horizontal x-axis direction. We hope that the center crossing point of the action of the four jaws can become the center point of the rotation of the chuck. But most of the time these 2 points don't coincide. What happens if they don't coincide? Suppose we were to cut a perforation in this square tube now. When we look at the chuck, the cutting head moves like this. So how do you rotate a center point that's not the center of the section? The travel distance of the cutting head on the x-axis is constant. As a result, the perforation becomes an oblique perforation. The same goes for the area of a round tube, except we have to analyze the area of the circular tube as a square. Then project the area of the square onto the circle. Other shapes of pipe such as channel steel, section steel is the same. Just project the area of the rectangular section onto the corresponding section. Fortunately, the current CNC technology manufacturers have added functions such as searching center point, calibration b-axis center point, and section correction to the system. Find the center. Then the error values of x and the axis are used to describe the processing. When the chuck manufacturer describes the b-axis movement center, instrumented test, if the two centers coincide, the watch doesn't change no matter how the chuck turns. Otherwise, the pointer of the table will swing back and forth. In this way, the error of the center of rotation can be measured most conveniently and accurately. The location of the center point is important. The four claws determine the location of the center point of the section. So what kind of mechanical structure is used in the chuck to ensure the position of the two groups of A and B claws? No matter how bent and heavy the pipe is, no matter how fast the chuck turns, it can be offset to a fixed position with a fixed distance. Understand the principle. It's clear how the chuck works. Some use chain, available connecting rod. Some use cylinders. The core is that the two grippers in Group A or B move the corresponding distance. If there are different steps, there will be errors. Ideally, of course, the two centers coincide. Therefore, generally everyone will set the adjustment device to adjust the error at the roller of the chuck. This is the accuracy of the chuck. I believe you can see it a few times and understand it clearly. The precision requirements of the pipe cutting machine bed. The accuracy of the y-axis is guaranteed by the heat treatment and machining of the machine tool. The axis perpendicularity test method is the same as the plate cutting machine method. Moreover, the numerical control system has compensation, and the influence of the axis error is very small. The concentricity of the chuck is what matters. Both cylinders are required to have the same axis of rotation, or else. Although the video was a little exaggerated, however, a small concentricity error on the machine tool will also be amplified to the parts. The closer the distance between the two chucks, the greater the machining error. Pipe error is a problem we can't solve. The pipes encountered in the actual processing are straight and curved, or the angle, the size is wrong. If you encounter deformation cannot recover the pipe, you may want to consider placing the machined surface on the curved side. It is in the z-axis direction. Error compensation function. For example, parallelogram tubes. The diagonal is very different. Let's try to understand how this diagram works. You can see why the squished pipe can't be cut out for perforation. Watch this video. Can cope with the vast majority of pipe processing errors.